Today's video is going to focus on nuclear reactions and nuclear equations. For this, you are going to need to know there are 5 different types of radiation. On this slide, you see 2 of them. On the next slide, you'll see the other 3. You should be kind of familiar with the terms that I'm using, but at the same time, these particles are new themselves. So the first particle that we're going to talk about is an alpha particle. And so when an alpha particle is released or absorbed, you have alpha radiation. What an alpha particle is it is the helium nucleus. What does that mean? Well, it's the nucleus of helium. Okay, so what does that mean it doesn't have? Are the electrons. So it's literally just the nucleus of helium. And so you have to memorize these different symbols that they have. This one on the left that I'm circling right now is the one that you're going to use in nuclear equations. Okay, this one can also be used, but it doesn't help you with the math that you're going to need to do. So I personally would always use this one on the left, but understand that this is what an alpha particle is. It's the alpha letter of the Greek alphabet. Okay, what's really important to understand about these is that this is a little different than we're used to. Okay, with a nuclear reaction, the top left number, okay, is the mass. Okay, so that's not any different than we're used to, okay, from knowing the atom structure, the atomic structure. For this one, though, the bottom actually represents the charge of that nucleus, okay? So the charge of the nucleus is always what's in the nucleus, so you've got protons and neutrons, so therefore it's really going to be the protons. So in this case, we have a positive 2 charge, and that's what's reflected here. How do I know that the example has alpha radiation? Well, I'm going to look at all of these, and what I'm going to do is I'm going to look for the 5 different types of radiation, and I see right here that is an alpha particle. So therefore, it is going to have alpha radiation. Now, you are going to have these all memorized. So the way that I actually remember alpha is that alpha is like the alpha dog, it's the alpha male, right? And so alpha is a he. Okay, so the alpha wolf is a he, and so what is he for helium? Well, it's got a 4 and 2. Okay, the next particle that you're going to have to be familiar with is a beta radiation. If I say beta radiation, what I am doing is I'm talking about a high energy electron. Okay, that's all it is a high energy electron. So I could actually say electron or beta. They typically do say beta, but I want you to become very comfortable with also seeing the word electron. So what is that for symbol? Okay, well, it just follows if it's a high energy electron, it's no different. It's just got more energy, right? So we've got a mass, which is 0, because remember the mass is always in the upper left. We've got its charge, which is in the lower left, which is a -1, and then your symbol is an E. Okay, so this is the better one to remember because this is the one that you use when you have to do all your calculations. Now, this one on the right is the beta letter of the Greek alphabet, and so it's really B with a little tail on it. You can leave it like this, or you can write the negative, which is its charge. It doesn't really matter. Okay, and then the charge is obviously a -1 looking at that. How do I identify that it's a beta in this bottom example? Well, I look for carbon, nitrogen. Oh, here's that beta particle, so I know it's releasing beta radiation. How do I remember that beta is an electron? It's the only one with that E, so E reminds me of electron. And then what I do is I figure out the formula from electron, knowing that the top number represents the mass, the bottom represents the charge, and then it's an electron. These are the other 3 types that you're going to have to be very familiar with. We've got positron, gamma, and neutron. So let's focus on positron right now. A positron is basically a positive electron. So really easy on how I remember this one is if I put positive electron together, I get the word positron. Okay, what is a positron? It is a positive electron. So therefore its mass would be 0, but its charge, because it's positive, would be a +1. You can either leave it as 1 or a +1. I typically do see a +1 written there. And then its symbol would be an E. Its charge, as you noted, is +1. So how do I know in this formula that they are giving off a positron? Well, I look and I see a positron right here, so I know that positron is emitted. The next one you're going to have to remember is gamma. Okay, gamma, all it is high energy radiation. It's actually not an individual particle, like it doesn't have a mass. It's just high energy radiation. This is the extremely dangerous one, by the way. So what is a gamma? This is gamma is the symbol, but what you want to do is you also want to know the math for it, okay? So a gamma is just high energy, which means its mass is 0 and its charge is 0, okay? And so you do want to write it more like this because that is how you're going to do the math. And this has gamma radiation. It should have a little like a Y. It kind of looks like a Y or like a kind of an alpha kind of downward longer. And how do I remember that gamma is what it is? What I do is I write out, okay, so I think of the word gamma, and then gamma has a double A, double M, and so it also has a double 0, right? So you have that 0 and 0. So that's how I remember gamma is 0 over 0, and then with that symbol. Okay, and then the last one is neutron. Okay, so a neutron is what a neutron is. Okay, so it's got its mass of 1, it's got its charge of 0, and its symbol is a lowercase n. Make sure you do lowercase because uppercase would be nitrogen. Okay, and then your charge would be 0. Now, if I look at this, oh, here's the neutron. Now, here's the key about neutron for this class, and I know I'm simplifying things by doing this, but we're just going to make it simpler for you guys. Okay, if you see a neutron, it is going to trump anything else. So I want you to focus on if you see a neutron, ignore the other particles. Even though they exist, you could identify them, but I want you to focus on that this is a what type of reaction if you see a neutron. Okay, so that's what my answer keys will always say, is if I focused on the neutron. You could say that you also have gamma radiation, things like that. That's absolutely fine. But I want you to focus on the neutron and make sure you always identify this. So a neutron, you have two options. Okay, you have fission and you have fusion. These are the two types of main nuclear reactions that we deal with. Fission is division. So what does that mean? Is that I'm going from one thing and I'm producing two smaller things. Fusion is like fusing things together. So we've got two smaller things going to one bigger thing. Okay, and so what I want you guys to do is I always want you to focus on, is it going from one big thing to two smaller things, or two smaller things to one bigger thing? Okay, and we'll get more into that on the future slides. So here's an important image about bombardment power and how far are these particles able to penetrate. And it's totally based on size and amount of energy. If you look at the above one with alpha, beta, gamma on the top, okay, and we've got the same on the bottom, which one has the most penetrating power? Well, that means which one can go through the most things. Well, if you look at it, it's obviously going to be gamma. And the same thing goes for the bottom. Okay, it's stopped by lead or concrete typically. Okay, the second question, what particle would positron most be like? Well, what is it? Because it's based on mass and size and amount of energy, a positron is most like what particle? Alpha, beta, or gamma? Well, that would be the beta particle, right? So just follow whatever the path the beta particle would be, and that would be the particle that the positron would probably be. So you'd see that the beta particle, I'm going to erase some of this. So you see that the beta particle can go through this or is stopped by that, and this beta particle is stopped by a piece of wood. So what stops that beta particle? In the first one, it's stopped by wood. In the second one, it either is stopped by plastic or somebody's hand. Okay, but notice that a beta particle can go through paper. Notice that an alpha particle is stopped by a piece of paper. And the reason why is because alpha has a mass of 4, so it's really, really large and it can't penetrate that much. All right, flight with magnets, okay? So magnets have charges just like these particles do, right? So beta has a -1, right? Because it's 0 over -1e. Gamma has 0, 0, and then it's that shape. And then an alpha is 4 over 2 with He. Okay. So what does that mean? Well, if it's in beta, it's got a negative charge. That negative charge means it's going to be attracted to its opposite, which would be the positive charge. That's why the beta particles go towards that positive end. Gamma particles have no charge, so therefore it would be not affected at all by having a positive or a negative charge magnet. And then we've got the alpha particle, which has that +2 charge, so because it is positive, it would be attracted to negative, and therefore that's why it kind of curves downward. Now the other one that I want you to understand is positron. So think about what a positron does and what it is, which is a positive electron. So 0 over +1e. And which side would it be attracted to? Well, because it has that +1 charge, it will also be attracted to something that's negative, just like that alpha particle was. All right. You are going to have to also not only identify the types of particles, the nuclear particles that you see in an equation, but you are going to have to be even more specific. And what you do is you identify the type of reaction depends on the location of that nuclear particle. What are those nuclear particles? Remember, they're the alpha, beta, gamma, positron. Okay, we really don't deal with the neutron because that will not be one or the other. The only exception is if you have a neutron bombardment. Okay, which you'll see examples of in your homework. Now, okay, if you find a particle and that particle out of those 4 or 5 are on the left-hand side of the arrow, you're going to write absorb, bombard, or capture. Now, they actually are more specific depending on what type of particle you have, but in this class, they're all synonymous. So you can use any ones you want as long as it's on the left-hand side, that particle. The right side is known as decay or emit, so you could use both of those, okay? So let's do an example problem below. When you look at this, what you first need to do is identify the nuclear particle. That nuclear particle is that guy right there, okay, which is either the electron or beta, and you can say either or. Okay, and now what you want to do is what side is this beta particle on? It's solely based off of the particle, the nuclear particle, not which you'll see in the next slide, not the blanks. It doesn't matter where the blanks are, it matters where the particle is. So it is to the right side of this arrow, right? So therefore you would use either decay or emission, okay? And either one would be acceptable, just understand that you can use both. So next one that we want to do is we want to actually do some math and some practice problems with this, okay? So like this follows, nuclear reactions also follow the law of conservation of mass, which means that mass can either be created or destroyed, or whatever mass you start with is the amount of mass that you need to end with. So when I look at this, I've got 242, okay? And that has to, instead of an arrow, think of it as an equal sign, and that has to equal everything that's on the right-hand side. So I'm going to do a basic algebraic problem. And so I've got 242, okay, equals 4 plus, and then some sort of number, okay, so x. So I'm going to solve for x, and I get 238 equals x. Now, if you can do this mentally or without writing it out, that is absolutely acceptable. All I'm grading is this answer right here, okay? So you've got the mass number on the top. Now let's focus on the bottom. So we've got 94 equals 2 plus, and then we've got another x, okay? And so when we solve that, we get 92. And so my job now is to not just leave it because we need to be specific on this. Notice that every single thing has a symbol right after it. So we're going to look on the periodic table for what that symbol is, and you always base it off of the bottom number of the atomic number, which is U. Okay, so it'd be 238 over 92U. Okay, and one thing I want you to note is that it's not a division. When I say over it, I'm just saying that's over it. It's not actually, you don't write a division sign. That's not proper. Okay, so let's do the next one. We've got x, okay, equals 32 plus 0. Okay, so x equals 32. Pretty easy. Okay, and then the next one, we've got y, or I'll say x again. X equals 16 plus -1. So x equals 15. I look up what 15 on the periodic table is, and that is phosphorus. Okay. All right, I'm going to erase this just a little bit. All right, the next one. We've got, this is a little trickier. So we've got 252, plus x, so 252 plus x, equals, now we've got this weirdo thing right here, okay? This guy is saying that we've got 3 neutrons. Just like in algebra, if you had x plus x plus x, you would say that's 3x. The exact same thing happens here. Instead of writing 3 neutrons separately, we just combine them, and we put a coefficient of a 3 in front of it. Okay, so what that is going to do is you're going to distribute that to both of these when you're trying to do your calculations. So it's going to be 3 times 1, so that number would be 3, plus 259. Now we've got 252 plus x equals 262, and so x equals 10. So I'm going to put 10 on the top. And then to solve for the bottom, we have 98 plus x equals 3 times 0 is 0, plus 103. So when you subtract that, you get 5 equals x. I'm going to put 5, and then I'm going to look on my periodic table for what that is, and that would be B. Make sure you write all three things. You need the mass, the charge, and the what the element is. All right, let's try the next one. Maybe we could do this mentally. So 55 plus a number equals 55. Well, that's easy. That's 0. Okay, and then the bottom number is 26 plus a number equals 25. So when you solve that, you should get -1. Okay, make sure you take your time through that. A lot of people will mess up and like write 1 or something like that, even though they know the math, but it just is, it gets confusing if you do, or it's easy to make a mistake, when you try to fly through these. So now we have 0 over -1, and what you need to do is remember those nuclear particles. Whenever you have a 0, a thing could go off, it should go off in your head because nothing on the periodic table has a 0. So something should go off in your head that you're going to be looking at one of those weird particles, those new nuclear particles, and 0 over -1 is an E or a beta particle. And then the final one is 15 equals what number plus 0? So that would be 15. And then the bottom is 8 equals what number plus 1, which would be 7. And so that would be nitrogen. All right, now the last thing that you need to do is you are going to have to identify the types of reactions that you see. And so the first thing you need to do in all of these instances is that you need to figure out, I just deleted that. What is that nuclear particle that you see in here? So in this case, I see a nuclear particle of that guy, which means that it is an alpha, and then I need to figure out what side that alpha particle is on. That alpha particle is on the right-hand side of that arrow, which means I can choose decay or emit. So I'm going to say alpha decay. It doesn't matter which one you say, just say one of those. Okay, the next one, I see a beta particle. So it's going to be a beta, and what side is that one on? That is on the right-hand side, so that would be emission. The next one I see is a neutron, okay? And so neutron means there's not neutron decay or anything like that. What you want to do is you want to cover up your neutrons, okay? This is how you do all of them. You cover up your neutrons, and if there's ones on the left and the right, you cover both of those. And so what you want to do is you want to look at it. So I'm going from 2 things to 1 thing. So what is going from 2 to 1? That would be fusion. And you don't say fusion decay or emission or anything, it's just fusion. Same thing with fission. So if it's fission, it's fission. You don't add another word to it. Okay, let's try the next one. We see this guy. It is a beta particle. And it is on the left-hand side, so you could say absorb, bombard, or capture. And I'm going to say capture. Or you could say electron capture. Both are completely acceptable. All right, and then the last one is I see a positron. So that would be a positron. And what is it? It's on the right-hand side, so that I'm going to say emission. You could also say decay. All right, hopefully you have a basic understanding of the 5 different particles of an alpha, beta, gamma, positron, and neutron, and then what types of decays they undergo, or what types of processes they undergo, which is absorb, bombard, capture, if that particle is on the left-hand side, or decay or emission if it's on the right-hand side, including fission and fusion, which are with those neutrons, and you either go from 1 to 2 things, which would be fission, because fission is division, or you could do fusion, where you go from 2 smaller things to 1 larger thing. Have a great evening.